Okay, our next student is Quynh Nguyen from Biological Sciences, and her thesis advisor is Professor and Chair Ananda Goldrath. So please join me in welcoming Quynh.
Hi, today I'd like to introduce to you a special group of cells that are critical in helping defend your body against infection and cancer. When your body becomes infected, a foreign invader will enter, and a group of cells called T cells will recognize this invader. The T cells will then multiply in number and become activated effector T cells. And these effector T cells can go on to kill the invader or recruit other cells to come help it in fighting off the infection. Eventually, a couple weeks later, you get better and the infection is cleared, and the majority of your effector T cells will die, though a small population remains as memory T cells. These memory T cells persist in your body for months to years after the initial infection, circulating through the blood and the tissue, always remembering what that original invader looks like so that it can rapidly attack it if it sees it again. My work is interested in a special group of memory T cells called tissue-resident memory T cells. These cells are unlike the other memory T cells because they do not circulate. In fact, when they enter the tissues, they stay there for the rest of their lives and possibly the rest of your lives. We're finding out that these tissue-resident memory T cells are becoming frontline defense against reinfection and, more importantly, very key in fighting off cancers, especially cancers that are localized to tissues, such as skin cancer, liver cancer, or brain cancer. So we want to understand how these cells are doing it so we can turn up their activity and make sure they're more effective in fighting off infection and cancer. However, it's not all good, because these cells, tissue-resident memory T cells, have also been implicated in autoimmune tissue-specific diseases. In this case, the cells are too active and they cause massive damage when they recognize things they shouldn't. This can lead to things like neurodegenerative diseases in your brain, asthma in your lungs, diabetes in your pancreas, and rashes on your skin. So here, we want to turn down their activity and create better treatments for autoimmune diseases. So the question I'm asking is, what makes a normal T cell become a tissue-resident memory T cells? What brings them into tissues, what keeps them there, and what helps them survive? Like I mentioned, understanding these signals can help us make better therapeutics, new vaccines, new cancer drugs, new autoimmune drugs. More importantly, many of our drugs currently are systemic. They target things everywhere, leading to side effects that you don't want. But if you target a certain group of cells in a specific tissue, you ensure that you can limit the side effects and make sure it's safer for all patients. Thank you.